Okay guys, we've made it to the end of financial. This is our last exercise, and this has got to do with having a compound investment where regular payments are being made. So in this instance, it's not just about investing the original amount of money. This includes making monthly payments to increase the value of that whilst interest is being added as well. So this is the last of the situations that we're going to look at. Alright, so let's get started on our final exercise for financial maths. Yay, we've gotten there. However, you do realise it means we have a sack coming. But that's okay, we'll get there too. Alright, so Sally saved $1,200 for a gap year holiday. And she reckons that she can add $50 a month to this savings, and she invested in an account that's paying 3% per annum. Alright, so to model this, the first thing we're going to have to do is sort out the interest rate. Remember, we've got 3% divided by 12 gives us 0.25. And to get that into the form that we want, we divide by 100 and we add the 1 to get 1.0025. She's making regular payments of $50. So to model this, we're going to have VO equals 1,200, VM plus 1 is equal to 1.0025 plus the $50 at the end. Alright, if we want to know what this looks like after 3 payments to see how her investment is progressing, we start off with 1,200. At the end of the first month, it's going to be worth $1,253. So if she's made a regular payment of $50, that means $3 worth of interest was added. After the next month, it's going to be worth $1,306.13. And after that third month, it's going to be $1,359.40. Now, we've looked at amortization tables before. Again, this type of situation can be modelled with the amortization table. So let's have a look at how that's done. Alright, up here, we've got payment number. It's just the usual setup. Payment number, payment made, the interest that's earned. This time it's an investment and we're adding to it, so it's the principal, the amount the principal is going to be increased by. So principal increase, and then we've got the balance. So remember, the first line is just 0, 0, 0, 0, and we put the initial investment, so $1,200. First line of an amortization table is always the easiest to fill out. Okay, so payment number 1. We know that she's making regular payments of $50, and what you'll need to do here is work out the interest. Now, when we did it over here, remember I strategically pointed out that it must have been $3 worth of interest. Well, there's our $3, okay? So if we add the 50 and the 3, the principal is going to increase by $53. So when you're filling it out, it's this number plus this number will give you this number. So if the principal is increasing by $53, the new balance is going to be the value up here, 1,200 plus the $53 to give us 1,253. After the second payment, again, she adds $50, but this time the interest was worked out on a slightly higher value. So the interest this time is $3.13. So if we add those together, we get $53.13, and then we add that on to this balance here. So 1,253 plus $53.13 gives me a new balance of $1,306.13. So you can see the way in which we complete an amortization table for this type of question. Okay? Let's have a look how we would use the financial solver here, and let's see how we're entering the information into the financial solver. So Sally invests $500,000 at 5.5% per annum, and that's compounding monthly. And she's going to make $500 deposits each month. And we have to find out the value after 5 years. So you've got the parts in the financial solver. So N is going to be 12 times 5 to give us a total of 60 payments. We've got 5.5% per annum. Remember, this is an investment, so she had to buy it, so she had to pay for the investment, so it's minus $500,000. And she's making regular payments of $500. So she's making the regular payments again, so that's another negative. So we need to put negative 500 in there. The future value is the thing we want to find out. So I've left a question mark there at the moment. And we know that the number of payments in a year is 12. The number of compounding periods is also 12. So when we hit enter, at the end of that time period, the end of 5 years, she's going to have $692,292.30. So remember, again, I've rounded to 2 decimal places because I'm dealing with money. All right. Hopefully that should help you get that last exercise done, and I'll see you guys more than likely at school by the time we get to this exercise. See ya!